first one is really the general workflow for how we use machine learning in LANDFIRE to model vegetation. We start with our predictor layers. So sometimes you might hear these called independent variables. And we have satellite image composites as our primary predictor variables. So I just have all the bands shown here. Blue, green, red, near infrared, shortwave infrared. There's 2 of those. So that makes a 6-band image composite. And then the values for those pixels are made by looking at all the Landsat Sentinel scenes in a given date range. It stacks them up and then finds a percentile. So we can pick whatever percentile we want of that stack of reflectance values. We often use the 50th percentile because it gives us the average. But we also look at like the 15th percentile or the 90th percentile. So that forms the basis for our predictor variables. Now for our model, we need our response variable. Sometimes you might hear this called a dependent variable. So it's the idea is that this variable is going to be determined in response to these predictor variables that we're putting in. So these are our training samples. I guess these are called a few different things, but we store this information in the LFRDB, the LANDFIRE reference database. So it's going to be field plots, and that's what it's shown here. These are, they're geolocated, they're spatial plots that we have high confidence in what's going on there. We have information from the field. Usually it's, it started off as field plots. Now we're looking at LiDAR. What kind of information can we get from LiDAR to say this is what the vegetation is like here? And we have some other methods that we are exploring too, looking at a consensus map and sampling on that, sort of a convergence of evidence from other maps. It's becoming more common to build up your number of training points so you can support those deep learning models. And then we're analysts, so we can't help ourselves from going in and checking things out with aerial photos and street view and whatnot. And so sometimes we do put in plots from just that desktop review. So those are the 2 components of our model. And what we need to do is extract all the values on those predictor variables and associate that with each of our training points so that we can say, all right, for this point, if we know the tree cover looks like this, what does the reflectance value look for in each of our different bands? And that's how it's building those associations and relationships. So once we have that, we can go ahead and build our model. And as we talked about before, we're using machine learning. So this is an algorithm. There's a lot of different algorithms out there. We've used, things like C5, Cubist in the past. You've heard of maybe random forest. It's a really common one. Now people are using neural nets and deep learning, and that can be substituted for this step as well. It's doing the same function. It's building predictions. And once you have that, the final step is to extrapolate out for all of those pixels in your predictor variables. You can now predict what your response variable is going to be. And that's how we get our maps. So we start with points in space, and we end up with a prediction for every pixel in our map. So, you know, it kind of seems like magic sometimes, and it really is. It's pretty incredible what we're able to do. And you know, our challenge is to take that information and put it all together into something that can be usable for creating fuels products and for other applications. So that's what I am going to explain in the following slides here.